So 7.1 is all done for trig. 7.2, we continue our look at the law of sines, but talk about this ambiguous case. It's really when you have angle side side. Three things can happen with angle side side. If you take a line, a ray, and you put an angle on there, that's your angle. And then you measure a certain distance, that's your side. And then the next side can be a certain distance also. Three things could happen. Perhaps you get a side that is too short. And now when it swings, it never hits this opposite side. The angle has locked it in, and that side is locked it in. And this side cannot reach that third side to create a triangle. So there may be zero triangles. Okay, just suppose, you have that ray, and the angle is locked in, and the side is locked in. But now you have exactly the right length, so it just touches once. It's really a right triangle. So you have one triangle. Now this could also happen if your side was long enough so that when you swung it over, that it did not create a side because it was coming past this. So that could also be one triangle. Either exactly right, making a right triangle, or a little bit long so that it misses, so it's only one triangle. The third way is if you had two triangles. So let's have our ray, and here is the angle and a side. Now let's put one side, or I guess the second side here, and that gives you one triangle. But if you swing this over and put that same side here, that same length, then you would get another triangle. You would have either this large one or this smaller one with A. And it would be the same angle, the same first side, and this same second side. But now you have two triangles. So that's why it's called the ambiguous case. It's because you may have no triangles, one triangle, or two triangles. Now in your textbook, you can look up and see what happens with this side and that side to see if you might have one triangle, two triangles, zero triangles. But in my, I guess, opinion, if you try to find a triangle and you do find one, then you'll certainly won't have zero. But if you try and you can't find one because of some error that shows up, then you know you're at the zero spot. If you do find one, then look for a second one. And if you can find a second, then you've got two. And if you can't, then you just have one. So that, to me, it's look for one. And if you find one, look for two. So, how about an example? Angle A, don't know it. Angle B, it's going to be 55 degrees. Angle C, don't know it. Let's see, we got this little side A is 25.1. Little side B, 8.94, and little side C, you don't know. So, if we look at these with A's and B's and C's, I always put the angle that I know down here at the left. So, this would be my angle B of 55 degrees. I could use this picture, also that picture. It would be angle B there. That's the one angle I know. Now, the side opposite has got to be side B, that little b. This has got to be the 8.94. That's locked in. Let's make the other side, in this case A, the 25.1. That means that this must be angle A over here, and this must be angle C, this whole side C. So now that you know that, and I do it this way so that it's always got this angle side situation set up. So, how do we find this another angle or another side? Well, if you're given two sides and only one angle, then you should be able to find another angle. Let's go for angle A, because A over the sine of A will equal little b over the sine of capital B. See, little a is 25.1 over the sine of, we don't know, angle A. And then side B, 8.94 over the sine of that angle, 55 degrees. If we cross multiply and divide by the third, you'll set up your equation. Let me put it sideways. So it's going to be sine A equals 25.1 times the sine over 8.94. 25.1 times the sine of 55 degrees over that 8.94. Okay, now, if you calculate this, remember, you need to have something that'll make sense. So let's clear this out. 25.1 times the sine of 55 degrees. Let's make sure we're in the correct mode. Degree mode. Yes, we are. Second quit gets me back. And now I need to go to the end of this. Divided by 8.94. So you get 2.299 for that right side. The sine is equal to 2.299. That's the sine of A. I just want A. So I should probably say that A is the inverse sine of 2.299. And when you calculate that, the inverse sine of 2.299, you get error. What? Well, when you get an error, you could have done something wrong, or the calculator may be telling you that you're trying to do something wrong. It's easier to go back and look at this. How big can the sine's value be for any angle? +1. How small can the sine be for any angle? -1. The sine goes from a -1 to 1 inclusive. 2.299 is not possible by taking the sine of some angle. Therefore, because we didn't even find 1, that's this first situation. And you could maybe suspect that 25.1, 8.94, it's a little too short. It was just up there swinging. But you now know for sure. So here's another example. Once again, how do I even know that this is angle side, that it makes a not very nice word? You can make a picture. I know that this is going to be that. So I'm going to put my angle A here, the 43.5 degrees. That means side A is across from it, 10.7. And I want angle side 7.2, which is C. That means this must be angle C, angle B, and side B. And it's because I want angle side set up this way. Now, is this thing long enough so that I get 1, maybe 2 triangles? Maybe. Let's see. the law of sines. So I can say that this 10.7 for A over the sine of A, which is 43.5, equals C, which is 7.2, over the sine of angle C. Remember, I keep doing this. You take that side that you're looking at stuff for, cross multiply, divide by the third. 7.2 times the sine of 43.5 degrees over 10.7. Now you can figure that out each time, but you'll get the same answer each time. The sine of C is equal to this. Take that with the unknown, cross multiply, divide by the third. And that's what that unknown is. So let's use our calculator to calculate this. Clear out the old 7.2 times the sine of 43.5. Close the parentheses, divided by 10.7. I'm getting 0.46319. Last time I got 2.29 or something like that, 299. That's too big. This one at least is not too big. So 0.46319. That's what the sine of C is. I don't want the sine of C. I want the angle C. So I want to find the inverse sine. Now you don't have to get rid of all those decimal places. You take the inverse sine of your answer from before. Second negation, which has answer. And you're in degree mode. 27.59. How many places? Well, this one went to one place, so we're going to go to one place for this. 27.6 degrees. That's what angle C is. Now, we know that's angle C. Add angle A, 43.5. We get 71.09. Subtract that from 180, or 180 minus that answer. Remember, answer always stores the last calculation. So 108.9 to one decimal place for B. And we can now use little b over the sine of what we just figured out, 108.9. That equals, let's use the one we already know, the 10.7 over the sine of 43.5. Cross multiply, divide by the third. So b is going to equal the sine 43.5 I'm sorry, cross multiply 10.7 times cross multiply the sine 10.7 times the sine of 108.9 over the sine of 43.5. Let's see what that gives us. So let's clear this out. 10.7 times the sine 108.9. Close that, divided by the sine of 43.5. And we get 14. Did they go to one decimal place here? Yes. So 14.7. Now, I've found one, I should look for another. How do you look for another? Well, we need another sheet of paper here sometime. I'm going to turn it over. But let's see if we have time. No, we're going to do this in the next episode. So we have found one triangle. This is the one we were given, angle A. given side A and given side C. That's the angle side portion of it. We can't change those, but angle B we can change if we take this side and swing it over here and say, here's my angle A again, or side A rather. It's the same length, but now I've got a new angle C. Well, remember, this is an isosceles triangle, so that means that these two base angles are the same. So this angle C, which is 27.6, this angle C, which is also 27.6, 180 degrees minus 27.6 will give us this new value of C. 10 minus 6 is 4, 9 minus 7 is 2, 7 minus 2 is 5, 152.4. So that is our new candidate for angle C. In order for that to be a viable angle, the three angles, A, B, and C, still have to add up to 180. We know A is locked in. Got to have 43.5. We said the other choice for angle C was the 152.4. When we add these together, we get 195.9. Well, that's too big. We can't reduce 152.4. This is how we would get it. That's 180 minus. We can't change the 43.5. That was given. Therefore, we don't have enough room even for these two, let alone an angle B. So there is one triangle. You're probably saying, well, then there's got to be an example you can do where there is two triangles. Yes. Let's suppose we have this. Give an angle A, side A, and side B. There's the angle side again. Okay, I'm going to find the other stuff. Let's see. A, the 22.8, over the sine of angle A, 55.3 degrees. And I know B, 24.9, over the sine of angle B, which I don't know. Cross multiply, divide by a third. So 24.9 times the sine of 55.3 degrees over 22.8 should be the sine of B. And if we take the inverse sine, we should find B. Let's do that. There's two steps here. So 24.9 times the sine of 55.3 divided by 22.8 gives me 0.87, etc., etc. We don't want that. That's what the sine of B is equal to. So I want the inverse sine of that answer, second negation. The inverse sine of answer gives me 63.879. They want one decimal place. So B is equal to 63.9 degrees. To find angle C, you take the 55.3 and add the 63.9. 9, 12, 9, and 11. 119.2. Subtract that from 180. 10 minus 2 is 8. 9 minus 9 is 0. 7 minus 1 is 6. So 60.8. Good. So 60.8. We do have some left over for another triangle. Now that we know there's enough angles, we can also figure out what C is. I'm sorry. The C over the sine of 60.8 degrees equals, let's go back to A, the 22.8 over the sine of 55.3. Cross multiply, divide by the third, so C is 22.8 times the sine of 60.8 degrees divided by the sine of 55.3 degrees. Well, let's see what that is. Let's see here. 22.8 times the sine of 60.8, close that parentheses, divided by the sine 55.3 degrees, get 24.2. So here's our first triangle, 24.2. Now, we found one, we need to look for a second one. So this is our triangle from the previous page. If we have a second one, remember, this angle's locked in, this side's locked in, and this side's locked in. But we can swing this over so that that side and that side are the same. This angle B was the 63.9. The new angle B has got to be 180 minus 63.9 degrees. So 10 minus 9 is 1, 9 minus 3 is 6, 7 minus 6 is 1, 116.1. That may or may not be good. Remember, we need to have enough for 3 angles. We've got to have the 55.3. We said the only other choice then for angle B would be this 116. Add them together, we get 4, 11, 7, 171. Yes, 180 minus 171.4. We've got room for another angle. 10 minus 4, 6. 9, let's see, yeah, 9 minus 1 is 8. And it's just 8.6 degrees. Is that all it is? That's all it is. So the other choices, 55.3. Angle B is the 116.1. That leaves angle C as the 8.6. That means we've got 2 triangles. These two have to remain the same, the 22.8, the 24.9. We've got to find our new side C because it's going to be a whole lot shorter than it was before. So C over the sine of angle C, which is 8.6 degrees. Go back and use A, our given 22.8, over the sine of 55.3 degrees. Cross multiply, divide by the third. C is equal to 22.8 times the sine of 8.6 divided by the sine of 55.3. Let's see what our calculator says for that one. 22.8 times the sine of 8.6 divided by the sine of 55.3 gives us 4 point, that's what C is, 4.14, I guess 4.1. So, and that makes sense. Angle C is a small angle, the side opposite is a small side, much smaller than the 24. So you lost about 20 units on that. So there are 2 triangles, the ones in black and the ones in purple. The ambiguous case.